Conference recording has started.
There we go.
It's showtime.
It is officially showtime. So, like I said, my name is Allie Depew, and I would like to introduce Dr. Steve Running. He is a Regents Professor at the University of Montana here in Missoula. Also, in 2007, something pretty awesome happened.
Oh, yeah.
What was that?
Well, it was part of the Nobel Peace Prize.
Absolutely. Dr. Running is a recipient of the Nobel Peace Prize for his work with climate change. And so this is someone that has a great wealth of knowledge, and I hope that you will take advantage of that today to ask any questions or engage in any conversations about climate change. So without further ado, I'm going to turn it over to you.
Off we go. And I'm getting better little by little with this video conference setup, so hopefully things will go well. This is really quite the setup. I can see both classrooms on my screen, and I guess you can see both me and my slide set, so this is pretty good. What I want to talk to you about over the next hour is the science of global warming. And I guess a good way, I think, for us to think about this at the outset is to think, here we are, January in Montana. And what's interesting now, we have two schools, Eureka and Poplar, almost opposite ends of the state. So this is going to be an interesting look at January in Montana from both ends. Eureka, what's the temperature up there right now?
I don't know.
About freezing.
Probably mid-20s, mid to upper 20s.
And how about Poplar?
Oops.
I never heard what Poplar said.
It's got to be 50 below at least.
Well, in the old days, it very well could have been. Because I've looked at the climate trends in Montana, and the single biggest change I've seen for Montana over the last 50 years or so is back in the 50s, it really could be 40 or 50 below zero in January in Poplar. And I imagine they haven't seen a temperature like that in decades. And Eureka, not quite as cold, but likewise the same situation, that 20 below zero, 30 below zero temperatures used to happen in January in Montana, and they don't anymore. We have really much milder winter temperatures in the past than we had in the past, and that's just an illustration of the real world of global warming. That it is what it says. The world's warming up, and Montana's warming up, and the part of our climate that most is warming up are these winter temperatures. So what I want to take you through is first a little bit of what we understand scientifically of why this global warming is occurring, and what we know about the causes of it, and what we measure worldwide are the current consequences of these warming temperatures. And then we're going to talk about what your generation gets to do to fix everything. And I'll start with the slide right behind me. It's a measure of carbon dioxide in the atmosphere. Started in 1958, and so you see down here at 318 parts per million, which none of us can really relate to what 318 means directly. But what's clear from this graph is every single year they've taken measurements, it's gone up. And in fact, just last spring, the global carbon dioxide went to 400 parts per million for the first time in probably tens of millions of years on Earth. And so it's clear that CO2 is going up in the atmosphere. These are measurements taken all over the world. This is just one example. And the big thing this tells us is that humans are having an impact on the global climate. Before this measurement started, we really thought that humanity was such a tiny part of the world that we really couldn't influence the entire climate. And this one graph started our understanding that we're changing the chemistry of the entire atmosphere right now. Now, the reason we care about changing the chemistry of the atmosphere, which otherwise might sound like a fairly inconsequential thing, is what we call the greenhouse effect. And this is a well-known bit of physics. The guy in this slide, Svante Arrhenius, figured out this physics in 1896. He got the Nobel Prize for understanding that molecules like carbon dioxide have this ability to operate differently with solar energy coming through, light energy that is allowed to come through the atmosphere, but it differentially blocks thermal energy, heat energy, from radiating back out into space. And so he just discovered these physical properties of these molecules. And what's funny is he matter-of-factly postulated over a century ago that if humanity kept burning coal for power and heat, which had started back in the 1800s, he thought, well, geez, someday the world's going to start getting warmer from all this CO2 in the atmosphere. I find this remarkable that this guy a century ago predicted exactly what's happening right now from basic physics.
So let's hear from our schools. Eureka, what have you heard about the greenhouse effect, or is there anything that you would like to add to what Dr. Running has said, or questions you might have?
Do you guys believe in global warming, or do you think it's bunk?
Okay, so you said that like the carbon dioxide emissions have gone up, and you said that it hasn't happened for like tens of millions of years. What if, like, you said that a lot of it is because of human impact? Why would it have gone up tens of millions of years ago if we didn't like have humans then? What would it have been back then, like that it caused the CO2 like in the atmosphere?
All right. The CO2 was stable in the atmosphere until about 100 years ago at about 290 parts per million. And so what I was referring to, I hope you didn't misinterpret, that the CO2 is really rather stable, and it's only this last 100 years that it has started up in the way that that graph shows. And so I hope that was clear. There's a famous graph called the hockey stick graph in climate science that looks at all these measurements for hundreds of thousands of years past, and it shows this same thing, that in this last 100 years the chemistry of the atmosphere has started changing dramatically, and it's from carbon dioxide from burning fossil fuels.
And so one of the things I think she's wanting to know about is the theory that this is just all cyclical, and this is part of one of those cycles. And I know you'll get to that later, but maybe you could speak on that.
Yeah, well, let's go right to the next slides. Actually, maybe we won't look at that one and get right to the measurements that we take worldwide that illustrate that the Earth's warming up. So that's the first step of what we as scientists want to understand. And so this graph summarizes all the different types of measurements that we take that illustrate the world is warming up. And you'll notice snow cover, glacier melt. These are things that we know are happening in Montana. The snow's melting about 2 weeks earlier than it did 50 years ago. The glaciers in Glacier National Park will be gone in about a decade. And so these are measurements we take right here in Montana that clearly show a warming trend of our climate. Now when we go off to the ocean, we can measure temperature of the ocean water. We can follow ice, like the Arctic sea ice that we know is declining. We follow all this by satellites literally every day. We know that the surface temperature of the ocean is warming up. Finally, we know that sea level is going up, and so as the ocean heats up and glaciers melt into the ocean, the sea level is going up about 3.5 millimeters a year. We expect by the end of this century that sea level will be 3 feet higher than it is now. Now, I recognize in Montana sea level is not the biggest thing on our minds, but if you lived in Florida, having a sea level 3 feet higher and then having a hurricane come by would be a very, very big deal. And so our coastal states are paying very high attention nowadays to the rising sea level and the rising hurricane damage that's occurring as these hurricanes come through. So first, we see clear indications of a warming world, as we show here. But to get to your question a little better, is to look at how do we know that humanity is causing this. And it's clear that CO2 is going up in the atmosphere. That's just a measurement that is measured all over the world, the South Pole, Mauna Loa in Hawaii, everywhere. We have dozens of stations measuring that. But what is it that tells us that this is not natural variability? That really is the key question that I think you were getting at. We can look back from ice cores. They drill ice cores out of the Antarctic that go down almost 2 miles, and these ice cores go back 800,000 years. They actually measure the chemistry of the bubbles in the ice cores, and that is what allows us to say with very, very high certainty what CO2 was in the atmosphere for hundreds of thousands of years into the past, is by analyzing these ice cores. Now, what those illustrate is that not only is CO2 rising in our current atmosphere, but we also know from evaluating isotopes that this CO2 is coming from fossil fuels. It's not coming from natural current sources like current plant growth and decay or burning forest or anything like that. The isotopic signature of fossil carbon is different enough from current carbon that we can see the difference, and it's clear that this increasing CO2 is literally coming from burning oil, gas, and coal. This slide behind me illustrates a couple of additional types of analysis. We know, for example, the winter is warming faster than the summer. And certainly in Montana, our winter minimum temperatures have gone up 10 degrees. Our summer temperatures have not gone up 10 degrees. They've gone up maybe 1 or 2 degrees. So we see right around Montana differences in how the warming is occurring. We know that night temperatures are warming faster than daytime temperatures. And so my question that I started with, if you go ask your parents and grandparents how cold winters got back when they were kids, I think they're going to tell you that it was much colder in January back in the 1950s and 1940s than it is now. And that's just a clear bit of evidence of global warming right here in Montana.
Let's move over to Poplar real quick. Poplar, do you have any questions about the causes of global warming, or as we were talking about greenhouse gases, or any comments about it?
Guess not. Better keep going. All right, so I've tried to summarize in this one slide the 4 things that the 4 climate impacts that I see are happening most in Montana right now. So these are trends of the last 50 years that we clearly see. I've already mentioned that the snowmelt is occurring a couple weeks earlier than it used to. We expect this continue into the future. The snowpack is going to last a shorter part of the winter season. in the west here particularly, and in Eureka, I think you'll have experienced this. We have much more active wildfires, bigger wildfires, a wildfire season that lasts much longer than 50 years ago. And the third factor that I see is significant, and again is most commonly you can see in the west part of the state, is the huge mountain pine beetle epidemics. And I'm sure you in Eureka have some whole hillsides of dead trees from pine beetle epidemics, probably really right outside your town. Because here around Missoula, there's forests of dead trees all over the place. And that didn't happen 50 years ago. The final major factor I see for Montana is our stream flow in the late summer is going down. And so our rivers, because the snowpack starts earlier, our rivers are just declining to a lower level of stream flow. And I see for Montana, for climate change in the future, that what is going to matter the most, what you all are going to deal with the most, is management of water in our state. We have multiple demands for water in the state, certainly for river flow and aquatic health, but for recreation, everybody I know loves floating rivers. And so having rivers without water is not going to work. My daughter used to live in Arizona, and down there they have rivers literally that have no water in them 11 months of the year. I don't think Montana will get that dry, but certainly we are losing river flow already. But additionally, our agriculture requires water for irrigating crops. And so this is something that is a major part of our economy, growing crops across the state, particularly more out in eastern Montana. And so we have to have a river flow to provide water for crop irrigation. And now we have a third demand on water in the state, and that's for energy production. Fracking takes a tremendous amount of water. Processing coal and tar sands and some of these ideas that are coming up for using more exotic fossil fuels all takes water to process. I don't know where that water is going to come from, because we already have rivers that are being depleted and irrigation water that's running dry. And what I see with the climate of the future is that Montana is going to be more arid, not less. And so this is a problem that I think the people of Montana are going to have to struggle with for the next 50 years. It's not going to go away, and we're going to have to get smarter at how we allocate and use and prioritize our water supplies.
Let's go ahead and stop and just have some questions from Poplar and Eureka. Now, Poplar, I know that your mic wasn't working for a second, but the bridge has fixed it, so you should be able to speak now, which will be great. So let's go ahead and start with Poplar. We'll see if that's working. There we go. Do you have any? Yay! I can hear you. I can hear you. Yes, loud and clear.
Wonderful.
OMG.
Guys, what do you guys have? Questions, comments?
Wait, I just don't have a question.
Global warming. I'm done.
Nothing? You guys don't have anything?
Just anything. Anything about global warming? You say something.
Warming.
I got something.
Say it. Go, Will.
I just want to comment. I came in kind of late to your presentation, but over the years as a kid, I saw.
Miles Brown, please report to the middle school office. You are being checked out.
I saw and heard a lot of things about global warming from politics on the news, and I never really understood it. I always thought it was just a bunch of BS. But your presentation kind of cleared up a few things. like that it's a real thing, and if we don't pay attention, and in a couple years, things could get bad.
Hello.
Well, that's really what I want to illustrate to all you students, is this is real science, this is real physics, this isn't politics, what's going on. Now, what humanity does is politics, but I'm trying to first give you a foundation of understanding of the pure science, of this is what's being measured worldwide. And so I find it really important that you see that this helps to give you some clearer understanding of this, because I go back to this fundamental graph of CO2. There's nothing political about that graph, one bit. That is a pure measurement by an electronic instrument, and no amount of political spin can change that fact. And that's an important thing we want to start with. Our whole discussion here is some hard scientific facts, and so that's what we're doing.
As we go through this presentation today, I know that being from the west side of the state, where there's a lot of timber industry, a lot of other things, going over to Poplar, where you're very close to the Bakken oil fields, and it'll be interesting to compare those two things to each other and how that plays a part into climate change and what ultimately our future is going to look like.
Yes, your two schools really are seeing the politics of this issue from two very different perspectives. I think the science is just pure science, but I can fully understand from Eureka to Poplar that the local politics on this topic could be dramatically different, and we're going to get to that pretty quick here. Once we're clear that global warming is occurring, which we scientifically now are, and we understand that adding CO2 to the atmosphere is what drives global warming, then we want to understand, well, where really is this CO2 coming from? And I've got to get out of the way of the graph. What you see is, this is worldwide, that CO2 emissions are increasing all around the world. So this is not just the United States at all. This is a worldwide phenomenon. What we also see when we try to understand what are the sources of the carbon dioxide, for many years the largest source was oil, primarily producing gasoline for transportation. But what you see here is, in the last decade, coal burning has become the largest single source of CO2 in the entire world. And so my conclusion from this is that's where you start in slowing down global warming, is let's start with the biggest emission source of all, and that, as you can clearly see, is coal burning. So I see then the next obvious step. Most coal is burned for electric power, and so let's explore what alternatives do we have to generate electric power in a different way. And I think the first thing that's obvious to me, I really like this slide because it encapsulates a number of issues about burning coal in one place. This is an osprey nest right on the University of Montana campus, and right next to the Clark Fork River. And these osprey chicks have 100 times higher level of mercury toxicity in their blood than is what's considered safe. And that mercury is coming almost entirely from burning coal. Because coal is not a processed fuel at all, you just dig it up and burn it. And so it has a horrendous pollutant load, and we literally can measure this pollutant load in osprey chicks. And yet, what do you see in the background of this exact same picture? Trains full of coal going to China to be burnt. Now, when that coal gets to China and is burned, 6 days later, the pollution comes all the way back across the Pacific Ocean and comes right back here to America.
I have a little question for the students. So, Dr. Running just said something that was pretty interesting. And when we're thinking about this, as Montana and being part of the world, a lot of times we think of ourselves. Well, we're in Montana. We're very isolated from a lot of other places. But he just said that a lot of our coal is going where?
To Asia.
To Asia and to China. Does anybody want to tell me, or does anybody have an idea as to why they are using so much coal and what is precipitating that use of energy?
Factories.
I hear factories.
What's the population of China?
Very large.
Four times larger than the U.S. 4 times. And what's next door? India. 3 times larger population than the whole U.S. So 1/3 of the world's population lives in India and China. And they all want electric power. All right, we'll continue. So what I see that the world has to do with electric power production is change our mix from what it is now. You see in the slide where almost all our power production comes from gas, coal, oil, and nuclear. And what we have to transition over the next 50 years, literally through the careers of you students, we have to change that mix to a mix of non-carbon emitting power sources. And obviously that's a big job, but we have 50 years to do it. We don't have to do it in 5. And so I want to give you a few ideas of what I see coming on that might give a few of you ideas on career paths that you might be interested in. The first thing I see is the electric power production is going to completely change from the way it is now. Instead of having huge power generating facilities like Colstrip, instead we're going to have 1 million smaller power sources everywhere. Solar panels on your house. My house now is a power generating plant. For example, and every single house of yours could in the future be a power generating plant. Think of how different that is from just having a huge big coal plant generate power and send it all over the state and all over the country. Instead, every little community will have power plants of their own. I think that'll be just tremendously better. It'll be a much better job creator for local communities because you'll, for example, have a few dozen wind turbines right outside your city. And so instead of your electric power coming from 1,000 miles away, you'll be generating it right close to your own community, possibly right on your very own house. I think that's going to be tremendously better and a more stable energy source than what we have now. Down here in the lower part of, I always move the wrong way, our little run-of-the-river hydropower generators. You don't need to build a dam. You simply have a little propeller in the water, and as the water flows by, it turns that propeller and turns a power generator. It's not very big, but since you don't disrupt the river at all, you could have hundreds of those down a river, just generating a little power all along the way, rather than a huge big hydroelectric dam. So you see how different the future of electricity is going to be from what we have now. All sorts of small power generators, and this is all with technology that already exists today.
So we've talked about a few of these. What does Montana have to offer? And I'd actually like to ask the students, what renewable sources of energy does Montana have to offer the rest of the United States or the world? Let's start with Poplar.
This is easy, come on.
What?
Solar panel. Now you're paying attention.
What do you guys got?
Wind
Like 3 or
turbine.
4 of them already here built.
Wind turbines.
Wow.
Wind turbine. So
Yeah.
is it ever windy in Poplar?
Yeah.
Okay, so yes, it's windy. So the one thing that you might have to offer that Montana could offer is the abundant wind source. What's something else that
Yeah.
Montana?
Absolutely. Wind power is already now the cheapest source of new electric power in the country are wind turbines. It's cheaper than any other new source. As long as you have wind.
Go ahead.
We have too much wind. I think we'd lose bearings in windmills.
Well, you know, that's part of of engineering the wind turbines to be better and better is being able to utilize wind from different speeds. They're a lot better than the earlier ones that would just get wrecked by high wind. That is huge energy production though. So having high wind turbines would be an advanced feature that certain places could make just tremendous amounts of electric power if you could keep the turbine going and not tear itself apart. Yeah, so out in Eureka.
I have a question. So we're talking about like renewable energy sources. Is there like any? Because I know like a lot of like the wind turbines in like eastern Montana, they like disrupt the migration patterns of elk. And there's been like other like putting dams in disrupts like river systems. Like what do you foresee any problems with renewable energy sources like affecting our wildlife or just our like ecosystem in general?
Yeah, that's a good question because anything we do will have some sort of impact. With wind turbines, the biggest problem early on was bird kill, that the propellers would really chew up the birds in flight. One of the things they now do is gear the wind turbine so even at high wind, the turbine's only going about this fast. And that's slow enough that birds can easily fly around it. So the bird mortality from wind turbines has dropped dramatically once they understood that problem and re-engineered the wind turbines. It's a good example of where with a new technology you discover a negative impact and you find a way to then change and mitigate that impact. Things like solar panels, I can't really think of much of a negative impact of solar panels, particularly on rooftops. I mean, your roof's just sitting up there anyway. I've heard that Walmart, for example, is putting solar panels across the rooftops of all their new stores. I hope that's correct. I've heard them say that that's their intention. So really, rooftops should all have solar panels. It's just free energy that we're not collecting. All right, for Eureka, this next idea is something that hopefully you can relate to even better, is bioenergy. In our forests nowadays, especially in western Montana, we have beetle-killed trees by the millions. And I've been by many of these places. They just have to saw down the dead trees, pile them up in a huge pile, and it's the biggest weenie roast in the whole county. That's all energy that we could have collected if we were smart enough. And I hope we're moving towards a future where, for example, we could have a portable power generator like this prototype behind me that goes out in the forest. You burn the trees on site, generating electric power, and put it back in the electric power grid. And you've cleaned up the dead trees and you've generated power on top of it. Those are the sort of ideas for bioenergy that I hope can develop, because otherwise we waste a lot of bioenergy just burning it into the sky. Another thing I see coming is going to be a dramatic change in cars. You're all of the age where you're getting your first cars, and in many cases, and I think the old piston engine cars of the past are going to be long gone quickly. The technology already exists for 100 mile per gallon cars. And I think your generation is going to see a very rapid transition in the technology of cars, and these clunky old piston engines are going to be a goner. And I think it's going to be fun to watch, like this turbine motor that I've got the graphic of there is like 3 times more efficient than a piston engine, just to give you an example. So there's really some amazing new technology finally starting to mature with cars.
Poplar, how is that going to affect farming?
Are we gonna drop power and torque for mileage? Do you think that's gonna happen? If you're getting 100 miles a gallon, are you gonna be able to pull a trailer to bale hay? Are you gonna be able to run a combine? Are you gonna be able to do any of that stuff?
It's not gonna help us then.
Yeah, those are the sort of questions for agriculture that are more relevant to you than 100 mile per gallon city cars. But think of this, there are electric powered train locomotives right now. So there's nothing inherent in the engineering of an electric motor that means it has to be small. Submarines are driven by electric motors. And so there's no reason that you couldn't have an electric powered combine. The limiting factor now is the batteries can't hold enough juice for a combine to operate for very long. So the electric motor is not the problem, it's the battery storage. And there's different ways of solving the energy storage, but you want to be thinking, you want to isolate the correct problem, and it's not the electric motor. Electric motors have huge torque. It's the battery storage or the power storage is the issue, not the electric motor itself.
I have a question on that.
Okay?
If you're plugging in a combine to get electric power, aren't you just getting the energy from burning coal?
I hope
Instead
not.
of oil, you're burning the coal to get the energy.
I hope we get past burning coal for electric power fast, because otherwise you'd be correct. It still would be more efficient from a complete system standpoint. But you're right that in a lot of ways you'd just be changing the emission from the combine itself to the coal-fired plant down the way. That's why we really have to rebuild the entire system, not just a piece here and a piece there. Another thing that's very clear when I look at home designs of the future. These are some pictures of houses that have been built. They're experimental houses, but they're completely zero emission houses. They generated enough electric power themselves to completely operate this house. And it's an example again of the future where every single house might be a power generator in certain areas, in many areas, from either solar power, from wind turbines, from bioenergy. I mean, we have a number of different ways we can generate electric power. And remember, we can also make our houses just dramatically more efficient than they are now. I show you some examples here of just in the last 30 years how we have furnaces now that are 96% efficient. Refrigerators that take a third of the electric power of refrigerators 30 years ago. You're probably familiar with all the new light bulbs. If we changed out all the light bulbs in the entire country tomorrow, it would cut our electric power use in this whole nation by about 20%. Think of that. Simply changing out old light bulbs for these new efficient light bulbs would make a gigantic difference if we did it across the whole country. So we have opportunities that we're just not taking advantage of that already exist with current technology. Another thing, did you hear a question?
Do you guys have a question?
I was just wondering about propane. What does it contribute to the CO2 or like? 'Cause it's a fossil fuel, isn't it?
Yeah, propane, methane, those are both fossil fuels, but they burn with twice the efficiency of coal. And so they are a lot cleaner. As a step from coal, we'd be much better off burning propane and natural gas than burning coal, because we get twice the power, electric power, and you don't get mercury and sulfur dioxide and acid rain from burning methane and propane. So in the long run, 50 years from now, I hope we're past burning propane also, but in the near term, moving from coal to propane is a good step ahead. Another big topic. Oh, yep, another question I see, Con.
If we get rid of coal as like for energy, doesn't Montana get most of its money from selling coal? How would that affect us?
I'm glad you asked that, because the coal industry likes to make it sound like they're a big part of our economy. Coal is less than 1% of the Montana economy. And if we had the policies in place to put up wind turbines, we could have just as much economic activity building wind turbines as the coal industry easily. So coal is not a big part of our state's economy, even though they like to make that threat, I'm sorry to say, to continue coal mining. All right, another really big, all-encompassing, I guess, issue that I see that your generation, I hope, can get really good at is advanced product design and recycling. We have a society today that just wastes such a tremendous amount of material in what we build, what we consume, how little recycling we do. You know, we're getting okay at aluminum cans. That's our best recycling, which is good, because making aluminum takes a huge amount of electric power. So it's a good example of something that we should recycle every single pound of aluminum. It saves us all the electric power of smelting more. But you should look around what you use all day long, and particularly what we throw away in packaging, in plastic bottles, in all the electronic gear. How many cell phones have you gone through already in your lifetimes? You probably have already had 2 or 3 cell phones, and the old ones just went in the garbage can. That's crazy. Why didn't we recycle those old cell phones, get the exotic metals out of the batteries in those cell phones and things like that? And so I think there's a huge opportunity to get smarter about the products we build, the things we consume, and how well we recycle them at the end of their functional lifetime. And that would open up tremendous job opportunities really in places all around the world, because everybody is consuming these kind of materials. The last thing I wanted you to think about, and it's really on a totally different frame of mind, this isn't technology, it's international politics of all things. Look at what the emissions have done of the different countries in the last decade. You see that in the US and in Europe, our emissions have started down. We're starting to make some good choices in our societies in the US and Europe. But look at India. And of course, look at China, who's just gone to the moon. China and India are 1/3 of the world's population. Those 2 countries alone. Their energy consumption has just exploded. And how are we going to negotiate with them to have a collective world strategy to reduce carbon emissions? We've got to talk and negotiate with them diplomatically in a way that we don't know how to do right now. This is my one diplomacy slide I was at the United Nations Center in Vienna. And so this is my one day of trying to be a diplomat. I don't do so well with a suit and tie on, I'm afraid. But we really have a global issue where consumption of the entire planet has exploded in the last 50 years. And both of your schools are in small towns in Montana. You probably think this sounds crazy, but if you ever take an airline flight to Asia and you land in Tokyo or Hong Kong or Singapore, where everything you see as far as the eye can see in every direction is humanity just devouring the planet, you would get a different perspective than what you see in your little towns. And what we can see globally is a hyperconsumption of the planet that just can't continue. We're just going to run out of resources. It's simply as that. And so how do we come to a global consensus for every country to contribute to this? I don't know. I think this is the hard part. The technology is the easy part. We already have a lot of solutions that aren't being used right now. Why is that? And so there's an awful lot of room for the social sciences in figuring out how to motivate societies. I think this is one of my favorite cartoons. Energy independence, preserving rainforests, sustainability, green jobs. What if it's a big hoax and we create a better world for nothing? There's people that claim that none of this is worth doing, that things are okay right now, and I'm sorry, that really just isn't true. And we can see that in multiple ways, that we've got to build a better world in the next 50 years, and your generation is what really has to lead it. My generation's too old and stupid, and just not willing to change, and your generation has to really pioneer these big new changes. And I encourage my daughters every day of the week to be part of that new wave of thinking. The last thing I'll do is a little ad for the University of Montana. We do have a climate change studies program here at the university, and so probably a lot of you are aiming at college in the next few years, and you might want to take a look at University of Montana's climate change program. So that's all for me. Do you have any questions? How about all those different job directions?
I see Poplar has their hands raised. Let's start with Poplar.
I had a question. As you know, there's a recent oil boom in North Dakota.
Yeah.
And it's coming over to where we are. And a couple months ago, I sat down and I was talking with a guy, and it turned out he was like the project lead for the drilling company. And he was telling me he got a couple of contracts. He's going to be moving over to Montana. He's going to start drilling.
Yep.
And I just kind of wanted, do you think that's going to start making a big change in the global warming?
Well, there's no doubt that oil from the Bakken is going into the global supply chain right now. They want to build pipelines to move it even faster. And so this is what the fossil fuel industry knows what to do. And so in a way, I don't fault them. They're doing what society is demanding. And so it's really up to society to develop different energy sources so there's alternatives. Whenever these fossil fuel booms occur, there have been booms like this all over the world. And of course, a small number of people get really rich, and they usually trash the local societies and local environments. And then when the oil runs out, they just move along to the next place. And I'm afraid that's exactly what eastern Montana and North Dakota are on the front end of one of those booms. and the bust will occur when the oil runs out. And I contrast that with the sustainability of putting up a wind turbine, for example, that'll run forever. It isn't ever going to run out.
Something eventually is gonna happen to it though.
Thank you.
I have a small question. Since we're all in high school, what can we as high schoolers do to help right now?
Well, I think the first thing you want to do is just look around the choices you make yourself and what you do every day. And even such simple things as if you drink a can or a plastic bottle of soda, do you put it in the recycling bin, or do you just not bother and put it in the trash? And so I think those little things, choices we make day by day are the start. Since none of you probably have houses, the energy efficiency of your home is probably something that you don't control, but you might talk to your parents about what are ways we can just use less electric power. It literally will save you money if you find some of these ways to reduce electric power use. You save money immediately. I think at your age, more than anything, is I think you want to get educated into these issues and start literally becoming politically active and making choices for society. Because society has to make a lot of choices in this next decade. And they need to be well-educated choices. And the thing that society cannot do is simply just keep making the choices we've made in the past without considering any other alternatives. Because we cannot continue the future that we have had in the last 50 years. We just plain will run out of resources.
Good questions.
I think majoring in international diplomacy would be a great one. Then you could go and negotiate with China.
Yeah, that's actually what I was just gonna ask you about. What are your thoughts, or how would you combat the emission from India and China? What would your solution be to? I mean, obviously we have the ideas and the ways to make it so that it's down, but how would you get through the barriers of the government and things like that so that we could use our knowledge to?
You know, I think the most important thing America does right now is to set a good example. Because in the past, America's been the biggest emitter on Earth until about 5 years ago. And we still, on a per person basis, are the highest carbon emission nation on Earth, with Canada and Australia and, would you believe, Saudi Arabia. And so we have to start by setting a good example. And I think we're on our way to doing that. You saw the emission rates of the U.S. is going down. So we're starting to head the right direction. But we can't start lecturing China or negotiating with China until they see that we're already doing it ourselves. And I think that's the point we're at in international diplomacy right now. And in fact, it was in today's news, just before I came over here to do this, that in the Los Angeles Times, that a pollution cloud from Beijing had come to Los Angeles. They can track it by satellite all the way across the ocean. And so the people in LA are starting to get the connection that just because that coal's burned on the other side of the ocean, it's global pollution. It isn't just China pollution, it's global pollution. And I think as we all understand that and all start, number one, showing from our own actions, and then number two, talking to China and India, that for them to be part of global community, they have to do a better job.
Excellent questions, everybody. We are just about out of time. It is 11 o'clock already. So
Yep.
I'd like to take a moment and just have everyone thank Dr. Running for speaking with us today. And if you have any questions, feel free to email them to me. I know your teachers have my email, and I will pass them on to Dr. Running. So thank you very much.
All right, thank you.